students and friends. We are now on our lesson incomplete dominance and codominance, and these are both are non-Mendellian patterns of heredity. And now our first illustration is a Punnett square between a red and a white flower. Here in the illustration, the red and white is crisscrossed, and we used Punnett square, and it produces pink flowers. And here in the second illustration, we can see that the flower is spotted, red with white spots, and this is the result of a codominance pattern of heredity. Okay, this is the result of a red and a white flower being crisscrossed. Using a Punnett square, we can also see how this becomes like this. And here in this illustration, we can see that two methods of non-Mendellian patterns of heredity. First is the incomplete dominance. Here produces pink from red and white flowers in the left side of the illustration. So the result is pink, and that is incomplete dominance. At the right side of the illustration, the red and white is crisscrossed, and it produces a spotted red with the white spots flower. Here in the third illustration, we can see that the genotype of red flower is RR, and the genotype of the white flower is WW. These two produce a spotted orange or red and white flowers, and this is an example of a codominance pattern. In this illustration, we can actually see the Punnett square of a red and white flower producing pink flower. This is an example of an incomplete dominance. So red is not actually dominance over white flowers. They are both dominant. So incomplete dominance, they blend their colors. So the intermediate color is pink, red and white producing pink colored flowers. Okay, you got it, guys. I hope so.
So again, we can use Punnett square with this non-Mendellian patterns of heredity. So using the characteristics, we cannot see any more small letters in this because these two characteristics are both dominant. Kung atong sabton kay makita man nato, both characteristics will prevail. So the intermediate characteristic is the resulting characteristics in the offsprings. So example, we will use this WW as white and RR red. Both are homozygous. So RR and WW. Using Punnett square, mao ni ang results. So pareho ra gyapon sa the same procedure with the previous kanang lesson nga ning gamit ta og Punnett square. Pareho ra gyapon ang procedure. So we will put in the first square kaning W and R. So WR, WR. So silang upat pareho ra og characteristics. The four offsprings are both showing the phenotype of being pink. Kay silang tanan WR man. 1, 2, 3, 4. So that the ratio will be 4:0. So all are pink. So let's try another example. For example, we will use this characteristic pink. The genotype is WR. And we will crisscross. Let's move here. Okay. So kaning WR atong i-crisscross. WR. Sa may resulting characteristics. On the first square, W and W. Next is W and R. Kani R and W, pero imong iunag suwat ang W kay mao may di nimo balihon kay mao na may pattern nga W ang nauna. So WR. 3 RR. So the genotypes of the offspring, 1 WW, 2 WR, and 1 RR. So may phenotype ani. So ang usa nga WW is white, 2 WR pink, and 1 RR which is red.
Let's have the phenotypic ratio. So 1:2:1. 25% white, 50% pink, and 25% red. So anha pa makita ang red o white. So in this type of crisscross, the kanang previous parents katong una jud nga white o red makita na nato anhi sa magitawag ni second filial generation. Ang first filial generation kani kare mao ni first filial generation gi self crisscross man nato ang mga offspring, so mao na ni gitawag og second filial generation. So mao rin ni about non-Mendellian patterns of heredity. I hope you got it right, guys. Thank you for watching, and I hope to see you again until next video. Thank you. Goodbye.